Thanks for the cheer to Dennis Chen. Alright. Problem 4, author guess. What? Does voting with bits give Evan bits? I think so. Yeah, I think when you use bits to vote, I gain like a cent or something. I'm not actually sure about that. I should double check that before I claim that. Actually, I don't. How do I check that? Bits. Okay. Well, congratulations to Twitch chat. You got completely swept. It's Robinson. Robinson.
This does not feel like an Evan problem.
Yeah, same person wrote 104. I mean, so let me tell you something about test development. People keep sending me hard problems. I don't get easy problems, so it's actually not very hard to like dominate the easy problem market in any particular packet. Yeah, Robin proposed both P1 and P4. All right. Problem 5 off, I guess.
Someone in the chat is asking what Jeff's rule is. Jeff's rule is something that was instituted at the IMO when Jeff Smith became the head of whatever. It says that 1, 2, 4, and 5 should all be different subjects.
Yeah. It's an informal motion. I don't think it's a hard rule, but it's sort of the expectation now.
It has been followed, at least in name, since 2012 or so, and generally people generally try for it on other tests like this, but it's not strictly followed on anything.
2012 is first. It was 2013 that Andrew won. Yeah, the reason actually 2012 was a lot of the reason because on 2012, 1, 2 were GA, and then 4, 5 were AG. So it was like GACAGN, and people decided that was not great. So then the Jeff rule started happening after that.
And then 2013 was the year where problem 5 was N in name only, right? Or was that 2014?
2014. That was the year I went. And I was very sad.
Yes, this is very sad. Number theory needs to have a resurgence.
Alright.
Why do people think I wrote problem 5?
Yeah, it's a good problem, so that's a compliment. 5 is
I mean, I'll take it, but like, no.
Is it out of character for you?
Yeah. Yeah.
Alright, one more. Alright, one more. Okay. Isn't Evan good at making bashable geo?
Yes, thank you, Evan.
I guess
appreciate it.
Oh, there's a tie. Okay, well, that breaks the tie. Alright, I thought I gave this away because earlier in the stream I mentioned I couldn't solve a problem, so it is indeed not my problem. It's also Hong Kong's. Yeah. Are the problems in HSO yet? I hasn't. Is there a day 2 thread on AOPS yet? I wasn't paying attention. USEMO. Oh, there's no day 2 general discussion thread. Alright, I'll make one. Why? I lost my compass. That's so funny. USEMO. Submit. Okay. I don't think your n should be negative. USEMO problems popping. Yeah. Yeah, the problem 5 has that like hit or miss property. It's kind of like I solved it and I was like I solved it today, but I think yesterday I might not have solved it kind of thing. I also tried a lot of stuff that I mean there's not that many things to try, I guess, that seem like they're feasible, but anyways, all right, let's go in order. So what oldest units would these go in? 6 is maybe 6 honestly might be like I either put in an LM Geo as a 9 point or as like an American Geo walkthrough. 5 I have no idea what to do with. I think it should go somewhere, but I don't know where. Russian combo might actually be the right place for it, even though it's not actually Russian. 5 feels like process, really? Like I feel like 5 is like a Russian flavored combo. And 4 is probably anti-construct.
Hong Kong tends to write Russian flavored combo.
Alright. Okay, so let's start with one 4. So you have this sum, and the sum is actually quite hard to do anything with. So USEMO 4. Thanks to Evan Chen is pro for the follow. Everything is set up. I don't think it's that unnatural, but let me go in order for the sake of narrative. So for USEMO 4, thanks SuperPie83 for the follow. So I mean I'm just gonna plug in n equals n p times p minus 1, which is like a full block. That's sort of the first thing I'm gonna try, because otherwise for most values of n it's very hard to compute this sum at all. But for n equals p times p minus 1, you actually can compute it and see what happens. So much easier to validate. Yeah, p6 is Oncon. Shout out to Joshua Jang from bfan0805. So what happens when I plug in p to p minus 1, what you have is, alright, I'm gonna get this wrong. So here, let me just write out what's happening. Dun, dun, dun. plus 3, p minus 1 minus 2. And then this goes all the way up to like p minus 1 to the 1. And we're going to reduce everything mod p. So reduce base mod p. The base is mod p, and the exponents mod p minus 1. That was a little thick, actually. Thanks to IMO Shortlist 2017 G6 for the follow, and Script Kitty for the follow. Okay, so when I reduce everything mod p minus 1, something really, like, basically what happens is by Chinese remainder theorem, everything comes out really nicely where you're going to get every base once and every exponent once. To maybe write this out a little more explicitly because it's not that easy to see. Like if I look in the first column, my stuff is like p plus 1, p minus 1 minus p, and then like 2p plus 1, p minus 1 minus 2p, and so on. So when all is said and done, at the end of the day, the stuff that's 1 mod p, I get every exponent mod p minus 1 exactly once. So it's like 1 to the 0 plus 1 to the 1 plus 1 to the squared plus 1 to the p minus 2. Okay, well, this is, I guess, p minus 1 mod p. That's fine. Then the same thing happens with a 2. Your exponent here starts at -1, but that doesn't really matter. What you'll get is 2 to the minus 1 plus 2 to the 0 plus 2 to the 1, all the way up to 2 to the p minus 3. The minus 1 is like whatever. Let's just make it p minus 2. Or take everything mod p minus 1. Thanks to 3 and 3G for the follow. Yeah, like p times p minus 1 is a good thing to look at because it's the first thing where everything, the block works out properly. Like, because the exponents are cycling every p minus 1, the bases are cycling every p. This is the thing that gives you like it's basically a rectangle. I think it's the best way to put it. It's like you have a p minus 1 by p rectangle. Okay, so how do I evaluate this? Well, if you forget the fact that we're trying to take things mod anything, I mean, it's a geometric series. So it's equal to 2 to the p minus 1 over 2 minus 1. So that's going to be 0 mod p because the numerator vanishes by Fermat's little theorem. Zoom out a little. So that's fine. And then the same thing happens for all the other things. So, you know, you get a 3. Thanks to I love Pi 31415 for the follow. You get this thing. This is another geometric series, which is 0 mod p. So for all the bases that aren't 1, you get a geometric series. And, you know, that stuff happens. So total minus 1 mod p. So what that means is if I take p times p minus 1, the left-hand side is just minus 1 mod p. So this is when n equals p times p minus 1. Okay, well, I want it to be 2020 mod p. So how do I modify this? Well, the last insight is that I can just have as many blocks as I want. So if you have k blocks, i.e. if I take n equals k times p minus 1, if you do the same calculation, you'll find that the answer is minus k mod p. So as long as you choose k to be minus 20 mod, so pick k to be minus 20 mod p and positive, you're fine. The end. It's very clean. Like deciding not to use primitive. Well, primitive roots is fine, I think. What happens is, see, in this, I have a rectangle, right? And in what I wrote in the rectangle, I summed by the rows. But if you sum by the columns and use primitive roots, you'll get the same result. What if my construction was negative?
Depends exactly how you proved it. But
yeah. Well, you need to know there is a primitive root, I think. Otherwise, you don't know. Yeah, I think if you don't know primitive roots exist, you don't know how to show it's a geometric series, I think. Unless you use Newton sums or something. Actually, Newton sums should work.
Newton sums work, but yeah.
How do you know p times p, or sorry, go ahead.
You go ahead.
How do you know p times p minus 1? I mean, I think because your exponents are cycling mod p minus 1 and your base is cycling mod p, I think this is a thing to try. Like, you don't expect it to work out right, I think. Like, if I didn't expect it to work out right, although it happened to, basically. But, yeah. Like New Long College said, it's like, because you have two different cycle lengths, looking at the LCM is, like, a natural thing to consider. You don't expect it to work out right, even though it does, but you should at least look at it. I'd say the main reason to look at a construction is because a couple things. One is that it's pretty hard to... Thanks, We Do Money, Curry, for the sub. It's pretty hard to compute the value for like a random n, and also like n should just exist. Like there's a sense in if I fix a prime p for a quote-unquote random n, whatever that means, it should work 1 over p of the time. So it's not like there's a shortage of values of n. Like you don't expect there to be like a unique n or something. I think those are the two reasons I would say. Yeah, those are two reasons I would say you kind of want to think about a pretty specific construction rather than trying to compute it in general, because you really can't compute it in general.
Yeah, so when you kind of start to look at the problem, if you try to evaluate the sum, there is nothing you can do. The 1 to the n, 2 to the n minus 1, etc. Those terms just don't do anything nice. If you try to sum from the other end, you'll end up with some random polynomial in n if you go a finite number of steps, but it doesn't have a nice structure. So you kind of need to figure out which terms can you group together in nice ways, and it ends up being not consecutive terms, but the terms that either have fixed exponent, where you use primitive roots or Newton sums, or have fixed base, where you do what Evan did here. With everyone asking how many points you'll get if you did various things, the main idea is probably worth something. It depends how you wrote it down. Negative n is probably a bit more tricky, but it also sort of depends which ideas you have, I would imagine. Like, with this solution, if you just say, okay, now set k equals negative 2020, you're, like, missing very little about the problem. There are probably other ways to find a negative n and miss substantially more, so hard to say in general.
What's the Mohs rating for this? I would say 10, but some people apparently don't agree with me. I thought it was just like there's not that many things to try, so try one that looks like it could possibly do something, and then it happens to work. But shrug. How many points would I get if I forgot to upload? Let's deal with that by email. Why were there no inequalities? No inequalities were chosen. Shrug. If you say minus 2020 mod p, that's fine, right? I would personally let it go, although that's the kind of thing you should just not do on a 1-4, because if you're at the IMO and the rubric is mean about it, you will lose the point. Get the end. Can you repeat the end of the solution? So the idea is when I take n equals p times p minus 1, when I look at that big rectangle, you do the calculation with the geometric series, you find it's minus 1 mod p. So if the total of a rectangle is minus 1 mod p, and I want a total of 2020 mod p, then you take p minus 2020 rectangles, for example. And it's like the sum of a rectangle is minus 1 mod p, so you take however many you need to get 2020 mod p. Okay. Any other questions on this? Best way to learn NT. I don't know. I think read the corresponding chapters of Otis excerpts and whatever other stuff I have on my website to start. I don't know quite what else to say. IMO 2019-4 is harder than P4 USEMO. Yeah, that's fair. That's fair. This is, I think, easier than IMO 2019-4. But well, I think they're hard in different ways. Like the IMO 2019-4 is a little technical. There's a lot of things that can work, but all of them involve doing a bit of details. Okay, I guess people think they're about the same. Whereas this one, there's not that many details, but you do need like an idea. Okay. Discussion. What is problem 5 in Mo's? I put 25 in my database, but I might change my mind when I see the scores. P5. But P5 is good. I will say P5 was, in the review process, like the most popular problem on the test by a significant margin. There were reviewers that told me I shouldn't waste the problem on USEMO. I berry bashed P6, is that good? I guess as long as you solved it. Okay, so USEMO 5, what do I want to say? So I tried some stuff that didn't work when I first thought about this problem, but I think the main thing that helped me was to think about, not rather than a 3-color case, what happens in the 2-color situation. So let's suppose that instead of living in the US, we live... Is there a country that has like a red and blue flag? I don't actually know off my head. Try Japan, red and white. Okay, that'll work. China. Yeah, but I want red. Okay, so we're gonna do red and white. That's fine.
There seems to be no country with only red and blue.
Yeah, I wanted red and blue because white is really hard to draw, but I'll just draw. It's fine. So if we're doing this problem, the Japan version of this problem, what it's saying is that I have like a polygon, or I said polygon, but really I think it's better if I write it as a cycle. So you're looking at like some reds and then a block of whites and a block of reds and then a block of whites, a block of reds. Here's a dumb example. And for example, you want to cut somewhere. I'm writing it in this notation because I think it's a little more natural this way. When you think about it, when you make the cut, you only break one block, so it makes sense that the blocks will matter. Also, the problem asks about blocks anyways because it's saying something about dazzling edges. Dazzling edges correspond to the boundaries of blocks. So, how to solve 2D problem? Or a 2-color? Well, what you can do is you can imagine that, I mean, if you think about the 2-dimensional problem, I keep saying 2D. When you think about the 2-color problem, I think you can solve the 2-color problem because like there's not that much you can do, and also it's kind of famous. Like, you guys may or may not know about the problems about, like, you know those problems where you want a continuous block of stuff, and the way you do it is you look at the partial sums and then use pigeonhole? That's what we're going to do here. For the Japan version of this problem, what I do is I go like R corresponds to +1, W corresponds to -1. And so we'll go like +5, -7, +3. And what you're looking for is you want to cross the x-axis again. Like anywhere I cross the x-axis is a place where I can cut it and get the thing I want. So to repeat that, the way we do the 2-color problem is you look at the partial sums. This is like, if you've ever seen a problem about, if you have a bunch of numbers, show that you can get a substring, which is a certain sum, which is 0 mod n or whatever. Also, USEMO 2017-4. It's all this idea. Like, if I'm interested in a continuous sequence, the way I do it is I get 2 partial sums to be equal. So, in this one, the places where if I have a Japanese patriotic polygon, you imagine it is going up and down, and then anytime you hit the x-axis is a place you can stop. And the hypothesis is that you're sorry, that's not what I meant to say. Not even hit the x-axis. Even if I just hit the same height, right? Like, is a place you can stop if you have a red next to a white. So I guess the Japan problem is actually very easy because you just take a red next to a white. But this is the sort of gist of it. It's like if you think about the various two-color versions of this problem, they all kind of have the same idea. It's I want to, if I'm looking at continuous substrings, I cut by looking at the partial sums and looking for partial sums that are equal. Okay, so unfortunately for you guys, we're in USA and not Japan. So let me see if I can draw a cartoon of the US flag. Oh, this is really hard. You know, it's fine. We'll just leave out the stars. That's a really bad flag. I tried. I don't think our flag looks anything like that, right?
I'm pretty sure the
did I
stripes
flip
are
the?
red and
Oh,
the...
yes,
Yeah.
yes. I flipped the colors. Oh my god. Oh, I was like, that looks really wrong. Not just because of the distortion. All right, let me fix that. I want to.
Seems fine.
That was really embarrassing. I got the colors on the flag wrong. I was like, why does that look so wrong? Okay, so what we're going to do is we're going to try to look at a two-dimensional version of this. So rather than in the Japan, I used 2 dimensions, but I really only needed 1. You could imagine just going up and down, right? So for the USA one, what we're going to do is I'm going to look at, you have red, and then you have blue, and then you have white, which I'm just going to draw as gray. And so rather than use 1D vectors, I'm going to use 2D vectors. So you have 1, 0 here. And those of you that know the solution know that these, you can pick different vectors and it will be more obvious what's going on, but I'm going to stick with these because I think it's more motivated this way. Why 2D? Because you want 2 different parameters, right? The patriotic is 2 conditions now. It's like the red equals blue equals gray. And so rather than just going a single number, I need to track 2 numbers, so I draw it in 2D like this, -1, -1. So what happens, a polygon, when I read around, you get like, you know, red, red. You go back to the origin, and a patriotic cut corresponds to this path, like colliding with itself eventually. So something like that. That's a very small example. I maybe should have drawn a bigger one, but it's fine. Right, so here's, if I had, let me write what this corresponds to. This corresponds to red, red, blue, blue, white, white. Sorry, there's 3 blues. Red, white. And so the hypothesis is, so no split means not self-intersecting. And because it's patriotic, you know it's a closed loop. This is the Nepal flag. Evan, how do I propose problems to the use of O? Clarify which contest you meant and I'll answer the question.
USA Vexillology Olympiad.
Okay, so, well, if it's not self-intersecting, that's literally it. I've encoded the condition in a much more natural way. It's like I have this polygon with sides that look like this. I know it's not self-intersecting. What can I say about it? And what we want is the dazzling edges correspond to the places where it changes directions. So what I want is for this polygon to have odd number of vertices. And you're like, okay, well, we can deal with that. Let's just look at the angles. So there's like 45-degree angles and 90-degree angles and 275-degree angles, right? No, sorry, 315-degree angles. Like here's a 315-degree angle, here's a 45, here's a 90. So if I let x, y, and z be the number of each of these, x plus y plus z is the number of vertices, which I guess I'll just call it m. And you also know 45x plus 90y plus 315y is equal to 180 m minus 2. So I divide by 45, you get x plus 2y plus, I wrote y twice, 7z is equal to 4x plus y plus z minus 2. Oh, is this not going to work with these angles? I thought it shouldn't matter what the angles are. Oh, ding. Oh, that's not good. Oh, I had in my head that this was like provably gonna work. That's bad for me. Shoot, do I have to do this by hand? Yeah, that's not good.
Wait, 270 can also occur, yes?
270, yes, 270 can also occur. Okay, so this is actually really bad for me. Yeah, there's 270. See, when I originally solved the problem, I did something about showing that there were certain, like, I think I showed 315 couldn't really happen because if I had a shape like this, because if you go up, you can't get back out. But for some reason, I thought the angles would have to work, but I guess they don't. Okay, scratch the bit about the angles. I can either do it manually or just switch to the smarter one. What do I want to do?
Switch to the smarter one.
Let's switch to the smarter one. Okay, so you can get this to work. This is what I did originally. But there's a thing you can do to make this more symmetric, which is that rather than using these three vectors I picked, we're going to switch it to these three. So the point of these three is that they're the vertices of an equilateral triangle. So now this picture looks different, and I'm going to have to redraw it. So I said red, red, blue, blue, blue. Yeah, so the original vector should work, but this one will give you the really clean solution. Red, gray. Okay, so when I do it this way, there's only two angles now. There's a 300-degree angle and 60-degree angles. So if I let x and y be the number of both, then x plus y is the number of vertices, and you get the angle sum. So when I divide through, this will actually tell me something concrete. It tells me like x minus y is equal to 3. So x plus y odd. That actually ends the proof. Yeah, so we took we decided the Nepal flag was actually more complicated than I needed, and so I don't know what country has a flag that looks like this. I don't think anyone does.
Yeah, so I think the main motivation to making your making these arrows the sides of an equilateral triangle is you want to somewhat preserve symmetry between the three colors. And there isn't, like, the way to do that, when you started with 1 and -1 in the 2D case, if you generalize to the 3D case, you, again, want to move to 2 dimensions to still encapsulate all your conditions. But to keep symmetry, kind of the only shape you can have is an equilateral triangle.
Yeah. So using these vectors, yeah, as Carl said, is symmetric. I do think this is, I think it could be a JMO 6. I don't think it would be unusually hard. I really think the main way you come up with this is you think about the two color case first. Like, I think anytime you have a situation where there's like a easier case that's still non-trivial, if you're stuck on the problem, like if you've run out of things to try, I think you always want to look at the really conspicuous easier cases. Like the way you solve it, I think, is you realize, well, the two color version is very easy, but similar to like a lot of things I've seen before, and then you adapt it to work for the three color version. If you try to solve the three color version from a vacuum, it's a lot harder. So I kind of showed you how I came up with that. I didn't notice that you could just make the vector symmetric. I had like 1, 0, 0, 1 initially. That will still work, but with more effort, because you need to more carefully analyze the non-intersecting thing. But the basic idea is to look at it using the vectors, and you come up with that by thinking about the two color case. Is there a solution by induction on n? I'm not really aware of any. I'm actually not aware of any solution that's not just basically this vector thing, which is why it's kind of scary to me. Like, it's not a problem where if you miss the main idea, you can make up for it by coming up with a different idea. I think you really do have to basically go this route. Yeah, well, JMO 2018-6 is actually hard, I think. I think this problem is... JMO 2018-6, I feel like, doesn't give you a foothold. There's nowhere that you can... There's no obvious thing I can think of that helps you motivate it. Whereas this problem, you can motivate it by talking about the two color case. Otis is indeed the name of an elevator. It's the name of an elevator company. What's the sketch of JMO 2018-6? The sketch is probably the solution. The solution's like 1 line long. But it's so hard to come up with. 1 plus n squared. I don't know. I think you'd have to look at this script. JMO 2018-6 is, I think I rated it like 40. Let me see my notes. Yeah, I rated JMO 2018-6 as like 40. Can you allow us to buy more emotes? I'm capped at a very small number of emotes right now because I only have like 8 subscribers. Once I hit 15, I think I can like add 1 more emote or something. What is JMO 2016-6? Is that like the geo? Oh, no, it's USEMO 4. Yeah, that problem is actually a 25. 90 viewers? Yeah, there were like 100 at some point yesterday. Why won't you publish more of your Mo's notes? Basically out of concern that people will take it too seriously. Is a very short. Also partly laziness because it takes me effort to rate every problem and like make sure I agree with the rating. It takes some thought. I figure USEMO plus IMO is enough. Yeah, yesterday there were a lot. Thanks to Dennis for the cheer. USEMO is a ploy to advertise the stream. That's pretty smart. It did come in the wrong order though, for that to be the case. I came up with the USEMO like I forget when. Well, it was like a month ago, and then I had the idea. Wait, I can run test review on stream. Like a week ago, which is. Yeah. The whole USEMO thing is like I think this is like the fastest I've gone from like maybe I should run a math contest to like actually running a thing. Like the whole test development process was less than a month. Can we watch ads? Sure. Sorry, did my shout out to Carl get acknowledged? Oh, did I miss it? Sorry, I might have missed it. Oh my gosh, there's a lot of shout outs I missed. Sorry, let me go through these now. Shout out to 2015. Sorry. Shout out to Joshua Jang from BFan0805. Shout out to Primitive Roots FDW from Bruh. Shout out to Carl Schildkott from Epic X Troll 3. Shout out to Buckshart Ban Everyone Beck Kurla from 69 Legend. I was not paying attention to the queue. Ah, jeez. I have to watch like 4 screens at once to run this stream. That was not meant to happen. Yeah, also I have a lot of hookeys. So like Meta 9 starts that horn sound music thing, and then there's like an air horn and stuff. So it goes like this. It's really fun. Alright, I'm ready to do. So, a little bit about the history of USEMO 6. The original version of the problem actually had 6 points with primes: A prime, B prime, C prime, D prime, E prime, and F prime, and it asked you to show that all of them are collinear. Anyways, yeah, so this is the diagram in the solutions packet. And if you want a one-line hint for this problem because you haven't thought about it much, I will say the following. 100, it's like 95% power of a point. Like the entire problem is radical axi, aside from one angle chase. Berry bash is better. The diagram is not... I think it's complicated because I put everything in one diagram, but the solution is short. I guess you guys won't believe me until I show you the solution. So why don't I just show you the solution? So critical claim. What's the Mohs rating? I have to think about that. Yeah, this didn't feel like a good problem for complex to me. It felt like a better Berry problem. So the main claim, A prime and D prime are on radical axis of X, Y, Z and the 9-point circle DEF. That's the big one. The main meat of the problem, I would say, is that that thick blue line is the radical axis of 2 circles that are already there. Thanks, TRDJ Dumpling, for the cheer. So, how do I get there? The answer is draw a bunch of circles. So, first, the points H, M, Y, Z, N. So, not N. H, M, Y, Z is cyclic, and with D. So, these 5 points are cyclic on the circle with diameter HM, which I'll call delta D. So this is the only angle chasing in the problem. I have to make this little green circle at the bottom that lies in the circle with diameter HM. Because of the way the X, Y, and Z are constructed, you get all the right angles you want. So MZ is like parallel to BH, so this is right angle. YZ is parallel to CE, so there's a right angle there. This one's given to be right. Why do we consider XYZ and DEF? Because it works is the very short version. Like the hardest part of this problem by far, I think, is noticing this red claim. It's the way you can access the perpendicularity, because there isn't a real way to deal with A prime D prime otherwise. Yeah, the statement has no circles and the solution has only circles. What's the motivation to try radical access? One bad motivation is just that you're asked to show perpendicularity through centers. It turns out to be dilated, but so the original version of the problem actually was like you would define the point T, like the point T we cut it out from the problem statement, but originally it was in there. Actually, it was called S, but we'll call it T for consistency. And it was like prove that TO was perpendicular to like A prime D prime, and that one was very radical axis. It's like do two circles. Well, you try to do a stream with the problems from FEOO. What is FEOO? Oh, the functional equation Olympiad. Maybe. You have to remind me when that is though, because I don't remember the date.
It's this Friday.
This Friday? Okay.
Friday/Saturday. It's occurring in different times in different places, but it should be done by this weekend.
Okay. Okay. No. So let's start the radical axis. I'm going to start by saying A prime is on the radical axis of some circles. Which circles? Delta D and XYZ. And that, I think, is just immediate. Actually, I'll say radical center of delta D, XYZ, and DEF, the 9-point circle. $100 viewers! Yep. Alright. So that's actually already one of the points that I need. What about D prime? So D prime is the radical center of delta D, the circle with diameter BH, the circle with diameter CH, and XYZ. I think. Wait, I think that's wrong. What is it supposed to be? Let me double check. D prime. Sorry, not D prime. No, D prime is... Sorry, I'm doing this out of order. I need to focus on P first. So I claim P is the radical center of BH, circle diameter BH, circle diameter CH, delta D, and DEF. Why is that true? If I look at BH, so this circle diameter, there's your HD, and I need one more thing, which is line YZ. Why do I feel like I'm missing something? It's because this should be the XYZ, not DEF. Okay, I really need to change these in my notes. I have like omega and gamma, and it's just really hard to read. How was this diagram made? Do you mean like typeset, or like how did we find the points? I can answer both actually. It's typeset and asymptote. How to find the points is I didn't add very many new points. Like actually most of the points here were in the original problem statement. Okay, so P is on the radical center because like X, you look at this green circle, this big blue circle, and then BH and CH, which are not drawn, but they have this HD radical axis. So X, the point P just lies on there because it's the intersection of YZ and DH. So that's fine. And then similarly for Q and R. And the upshot of that is if you know both Q and R are on there, then it follows that QR is the radical axis of AH and XYZ by symmetry. So once you have that, D prime is radical D prime, which is like QR intersect EF, lies on radical axis of XYZ and DEF. So that completes the proof of the red claim. Ah, Carl, you figured out how to time people out.
I agree.
Thanks to nprime06 for the follow. Okay, so at this point, I claim I'm actually just basically done. Once I have the radical axis, how do I get the centers? Well, we're going to let T be the reflection of H over S. Then I'm going to shrink this diagram slightly. Yeah. So then OT is perpendicular to A prime D prime since Sn is perpendicular to A prime D prime. Sorry, I should clarify S is the center of XYZ. How do you draw the circumcenter of 4 random points? You should first see if you can draw the diagram such that you draw the circle first rather than the points, but if you can't, then you just kind of have to like draw the perpendicular bisectors.
Or you can guess the location of the circumcenter and repeatedly try to draw the circle and see if it works.
Why is circum... Is it still censored? I thought I blocked the... I thought I disabled the... Yeah, it works fine, right? It used to be... When I first streamed it was censored because I hadn't adjusted the filters yet, but I like turned them off yesterday completely after a while.
Uh-oh.
Did I... It's censored for you still? Wait, it's coming through fine in... Oh, some people have their... Okay, I don't know then. Thanks to Store 69 Legend for the cheer. Let me read what it was. Oh, his cheer got deleted, that's why I can't see it.
Oh, sorry about that.
That's fine. Okay, so OT is perpendicular A prime D prime because it's perpendicular line through the centers. So now I just need QR. And I claim AT is perpendicular to QR since you look by looking at line through midpoint of AH. And S. So what happens is because QR is the radical axis of AH and XYZ, this midpoint here through S is perpendicular to QR, so AT by homotopy at H is 2. So I think I really botched that presentation, but that is actually the end of the proof. Like, this is the entire solution on the board. I like barocentric more, but the solution is so short. Like, it's... I don't know. To each their own. What happens to the orthocenter of a triangle is the circumcenter of another triangle and vice versa. They have the same Euler line. And the same 9-point center. I don't know if there's anything stronger I can say. I have to think about that. I think there's some condition I can say, but I don't know what it is. Okay. But yeah, this is literally just all power of a point. Like once you, definitely, I think the hard part is realizing this claim. Once you have this claim, then you kind of just piece the solution together by doing the proper radical xi. I don't think you noticed the claim first. Relate A prime and D prime. That is fair. I don't know. In test solving, I heard that people got the claim first. Also, in test solving, I had some. In test solving, I had some very strong geometers who didn't solve the problem, which is why I was willing to put it as 6. A bunch of the reviewers told me it should be 2-5, but who? I mean, I don't really know if I want to say on stream which people didn't solve this problem. But I will say some of our reviewers who have like historically been extremely strong were not able to do it, which is why I was willing to put it as 6. D prime was radical access of x, y, z, and ahef. I don't know. I didn't have the idea to look at x, y, z. I got confused because I kept thinking that because O was involved, I was supposed to use the circumcircle, and for some reason I just did not draw the 9-point center. And I was like, well, like there's a 9-point circle in here, and I didn't draw the 9-point center. I kept trying to do stuff with O instead. It's like, what is it the radical axis of with O and something else? But it's just wrong. It's all dilated. You actually want the circumcenter of x, y, z. Thanks for the cheer. Can you play what?
Fortnite.
Fortnite. Oh. Can you play Fortnite on the next stream? I want to play Fortnite. I actually haven't played before, so I don't know. It's like if you draw ABC near equilateral, it's easier. I believe that.
You can actually draw the circles, and they don't just go off into oblivion.
So for people asking, so I have a prize. In the prize thing, distinction is 14 points. I'll recognize everyone that gets at least a score of 14. And honorable mention is like 5 to 7 after top score. So HM on USEMO is actually hard. It's like a leaderboard. I plan to post distinction, which means anyone who gets at least 14 points, there'll just be a big list of them. And I think this, yeah. 14. Yeah, I think this is deliberate because I think like solving one problem per day is like something I think should be recognized or something. I think the IMO honorable mention is slightly too low, but like USEMO is really bad at this. You don't get any recognition unless you're top 24. So that was my idea. Is like if you can get a 1 and 4, if you can solve it easy, if you're good enough to like solve the 1 and 4 now, then I think that's something I can recognize. Watch me lose points for bad proofs. Well, as long as they're correct. Who makes the rubrics? Problem captains. Who haven't done it yet because we don't even have the papers to start. Yep. I think like 14 is a good goal to aim for the first time you take an Olympiad. No, it's just like try to solve a problem each day. So, hence why that. What are rubrics? We haven't decided them yet. Can you change the 13? No. What do you predict the highest score will be? I think some people definitely got 35. I don't know if anyone got all 6 problems. I haven't been listening to the chats enough. It comes down to like whether the people that got problem 3 are also like geometry enough to do problem 6. How much would 14 be in JMO? It depends on the JMO. The JMO difficulty is wildly varying, to say the least. Because what happened was when JMO first started, it was very clear they wanted JMO 3 to be USEMO 1 level, JMO 6 to be USEMO 4 level, and then like JMO 1, 2, 4, 5 you slot accordingly. And that's very not necessarily true anymore. Like now it's more like JMO 2 is USEMO 1, JMO 3 is USEMO 2-ish, maybe fudge a little. So it's kind of up in the air. How would you say this is compared to USEMO? I think this is... I mean, the goal of USEMO was to be about IMO/USEMO in difficulty. I think on average, we did about right. Like, if you look at the average of all the problems. Like, but the individual days, I think day 1 was pretty hard, day 2 is relatively easy, but I think USEMO IMO is like pretty carefully... It's pretty close to the midpoint of the 2 days. Moo? Question mark? Day 2 was hard too. Is it normal my scores vary wildly depending on subject distribution? Some people... Oh my god, someone redeemed an ad break. But I do think when you're first starting Olympiads, you have a lot more variance, and then as you get better, your variance also kind of goes down. We need USEMO. How does that work? USEMO should be a thing. I agree, but I don't know if I have the resources. We didn't do it for the first year because we were worried that... Well, I was basically just worried we were not going to be able to grade them. So this is sort of like the pilot, and then if grading goes well and I expect to get continued supply of volunteers, then we'll try to do a UCJMO, but unclear.
You also need easy problems, and these are hard to acquire. Easy, not as in easy, but like easier than what you would put on a USEMO difficulty test.
Well, we need good easy problems. It's not too hard to make up bad easy problems.
Fine.
If this was the IMO, how the USA team do, I think in many ways this test feels a lot like IMO 2019 to me. Like even down to subject distribution. For the USA, they would I think USA would kind of get 1, 2, 4, 5. A small number of people would do 3, and 6 would be pretty well solved. USA did pretty bad, really? Did this basically become a practice run for USEMO? Yes. Not just for you guys, but also for AOPS and the graders. I think whatever goes wrong on this test, we'll learn from for the actual USEMO that apparently now exists. P2 seems not in the IMO style, I agree. It's more technical than what would happen on the IMO. USETSTST. Oh. Make an online camp in a Discord server called UCMOP.
Anyone is free to do this.
Is USEMO as the same format as USEMO? Yes, by the transitive property. Why no 2.5 Geo? I don't know. We just picked this test based on what we got.
You can't have 1.4 Geo and 2.5 Geo and 3.6 Geo.
But apparently you can have that for combo because that happened at my IMO.
Everybody loves combo.
Thanks to 69 Legend for the cheer. Is it the same portal on AOPS? Oh, I don't know. We don't... It probably will be, is my guess, because I don't think it makes sense to ask AOPS to, like, redevelop it for no reason. But, I mean, We don't even know for sure it'll be on AOPS, although I suspect it will be, because if the AME is on AOPS, the USEMO probably will be too, because the technical setup for USEMO is definitely harder than for the AME, because AME is 15 3-digit integers. Yeah, if you don't like the problems, get top 3, and then you get to start proposing too. According to William, GL should be banned for IMO. No comment. I was wondering whether there would be a submit button. Shrug. I don't know. How long have you been live? I started at 7, so right after discussion opened. So I've been online for like an hour. And propose. Well, once you graduate from high school, you can propose too. Like, I think one of the nice things I was able to do for USEMO, because it's not a high stakes contest, like it was just like anyone can send me problems. So if you have a problem that you think is cool, send it my way. Okay, since I have like 90 viewers here, I want to do a quick straw poll for my planning. So if we run this USEMO again, we're going to run it in the fall because otherwise it's too hard to schedule. The question I want to ask you guys is, would you guys want to do it fall 2020 or fall 2021 for the next one? Please respond to A for Apple O2. What was the comment? Did I miss it? Run it in fall 2020. Okay, that sounds like it's unanimous. How many points for proving that first 3 lines concurrent but not the fourth? Probably 0, honestly. Because the concurrence of the first 3 lines follows from something about... orthologic triangles is what you're looking for. And yeah, it's sort of not the point of the problem. It doesn't help you with the main part. Please create a UCJMO. If I can get enough graders, is a very short version. Okay, so it sounds like people want to do this in the fall. It's good. Yeah. I do think, yeah, if you have good problems and you're in high school, I do recommend saving them for like a large contest. I definitely, I don't know. I mean, I guess you have to wait, which is kind of annoying. But yeah. Can you do USEMO to match a bit with Shanghai time? How would I do that? USEMO is big. Will you release official solutions? Yes, we will. I haven't published them yet because 1, there's always mistakes that get caught during the grading, and 2, I want to clean them up as I read AOPS and see if there's new approaches that I want to incorporate. But we will eventually post official solutions. Will marking schemes be published? Yes, we plan to publish marking schemes.